This is a video about acids and their formulae. The four most common laboratory acids are hydrochloric acid, sulfuric acid, nitric acid, and phosphoric acid. Hydrochloric acid's formulae is capital H, capital C, and then a lowercase l. Sulfuric acid, which may be spelled with a F instead of the PH, its formula is capital H, then a subscript 2, capital S, capital O, subscript 4. Nitric acid's formula is capital H, capital N, capital O, and then subscript 3. Phosphoric acid's formula is capital H, subscript 3, capital P, capital O, subscript 4. The previous acids I showed you were all mineral acids. Now we're going to have a look at the formulae of some organic acids. So organic acids in chemistry are anything that contain the element carbon. So the acids we're going to have a look at are ascorbic acid, carbonic acid, lactic acid, citric acid, ethanoic acid, and pentanoic acid. So the formula for ascorbic acid, which is otherwise known as vitamin C, is C with a subscript 6, H with a subscript 8, and O subscript 6, with the C, H and the O all being capitals. Next up we have carbonic acid. So carbonic's formula is capital H, subscript 2, capital C, capital O, subscript 3. Lactic acid's formula is C, capital C, 3, H, 6, O, 3. Citric acid, its formula is C6, H8, O7. Ethanoic acid is C, H3, C, O, O, H, where all the letters there are all capital letters. And pentanoic acid, which is old-fashioned name is valeric acid, is capital C again, 5, H10, O2. So what exactly do those formulas mean? Well, if we take a common one, we'll go with sulfuric acid. Its formula was H2SO4. If we look at the capital letters there, that tells us that this contains hydrogen, sulfur, which again can be spelt with a PH or an F, and oxygen. So that's what the symbols are. The subscripts tell us how many of each element there are, and they relate to the element just in front. So actually H2SO4 is just chemistry shorthand for 2 hydrogens, 1 sulphur and 4 oxygen atoms. You don't need to know that for this topic, but I thought I would just explain what a chemical formula is actually telling you. By far, the most common alkali that you'll come across is sodium hydroxide. So that's sodium hydroxide, and its formula is capital Na for the sodium, capital O, capital H. The next most common one that you'll tend to come across in class is potassium hydroxide. So that's potassium. Be careful, lots of people like to spell it with 2 T's and 1 S. And then we've got hydroxide, which is capital K and then capitals O and H. The next alkali I'm going to show you is lithium hydroxide. And the formula for lithium hydroxide is capital L, small I for the lithium, capital O, capital H. Another one that's quite common to see is ammonium hydroxide. And the formula for ammonium hydroxide is capital N, capital H, subscript 4, capital O, capital H. The next 2 alkalis formulae that I'm going to show you are slightly more complex because they make use of brackets. So the next one we've got is calcium hydroxide. And calcium hydroxide's formula is capital C, small a, open brackets, capital O, capital H, close brackets, and then a 2. Magnesium hydroxide's formula is very similar. Where we've got capital M and G for magnesium, open the brackets, capital O, capital H, close the brackets, and then subscript 2 again. If we just explain what is this subscript 2 doing with these brackets, so what does this formula actually mean? So if we have a look at magnesium hydroxide's one, that means that we've got 1 magnesium and 2 of these OH groups. And rather than writing this twice, we pop brackets round about one of them and then put the 2 subscript on. If we have a look at all of the formulae of the alkalis together, then there's a clear and striking similarity between them all. Every single one of them has this OH group attached. Because it's 2 capital letters, this OH must have 2 elements in it. And those two elements are oxygen and hydrogen.